The last class we are discussing about the effects of electric current. We discuss the different type of effects of electric current. First one is the heating effect, lighting effect, mechanical effect, magnetic effect, and chemical effect. Among these 5 effects, in heating appliances, heat energy, electrical energy is converted into heat energy. That's the heating effect. Then in electrical lamps, electrical energy is converted into light energy. That's the lighting effect. Then in electromagnet, the electrical energy is converted into magnetic energy. And in electrical fans, mixie, grinder, and electric motors, this electrical energy is converted into mechanical energy. That's mechanical effect. Then in chemical cells, electrical energy is converted into chemical energy. That's the chemical effect. For example, in case of chemical cells, lithium ion cells used in mobile phone, nickel cadmium cell used in emergencies and searchlight, dry cell used in searchlight, and lead acid cell used in automobiles and inverters. In all these chemical cells, electrical energy is converted into chemical energy while charging. While charging a chemical cell, electrical energy is converted into what? Chemical energy. But while we are using that, means while discharging that chemical cell, this chemical energy is converted into electrical energy. Sometimes during examination, then we ask, what is the energy conversion during charging of a chemical cell or charging of a dry cell? That is, during charging, electrical energy is converted into chemical energy. They are stored in the form of chemical energy. And during discharging of these chemical cells, chemical energy is converted into what? Electrical energy. This is the energy change in chemical cells. And this chemical effect they are going to study it in chemistry classes. And the mechanical effects we are going to study in our physics next chapters. And magnetic effect are already studied in 9th standard. And the remaining 2 effects, that is heating effect and lighting effect, that we discuss in this chapter. Okay, first one is the heating effect. In the earlier class, we already discussed about the different heating appliances. In the figure, you can able to see the different heating appliances. That is, the first one is the soldering iron, and second one is the electric heater, and third one is the immersion heater, and others are also heating appliances are there. That is the most familiar one, the iron box, heater, electric kettle, immersion heater, and water boiler is there. You just listen the figures of that heating appliances. In all these heating appliances, the electrical energy is converted into heat energy. Our question is that how does this electrical energy change into heat energy in this type of devices? We want to find out the answer for that. For that, we can conduct a simple experiment. The materials required for this experiment is a nichrome wire of 5 cm length or 10 cm length, then a 6-volt battery, connection wires, and we can use an aluminum wire also. You just observe the circuit, figure 1.1 in your textbook. Oh, just observe that figure. In that figure, a nichrome wire is connected in series with a 6-volt battery through a switch. Then, when we switch on the circuit, the current, means electrical energy, flow through the nichrome wire. When electrical energy flow through the nichrome wire becoming red hot. You just observe the figure, observe the video. That is, when you just observe that animation, you can able to see that when current, that is electrical energy, flow through the nichrome wire, it becoming red hot. Our question is that can this nichrome wire can generate electricity or heat energy? Sorry, can this nichrome wire can generate heat energy? No. According to law of conservation of energy, energy can neither be created nor be destroyed. It can only convert from one form to another. Therefore, this nichrome wire can't generate heat energy. It can only convert from one form to another. Then our question is that how does, again the question coming, how does this nichrome wire convert electrical energy into heat energy? How does this nichrome wire convert electrical energy into heat energy? Okay, for that we can analyze this circuit by using, we can analyze the experiment, we can analyze by examining the current and voltage through the circuit. We can analyze the experiment by examining the current and voltage through the circuit. We want to measure the current and voltage through this circuit. You observe the figure, circuit diagram. Here, to measure the current and voltage, use a voltmeter. We can measure the potential difference, that is voltage. By using an ammeter, we can measure the current. That is the device used to measure the potential difference or voltage is a voltmeter, and the device used to measure the potential current is the ammeter. Okay, then connect the voltmeter in parallel to the nichrome wire and connect ammeter series to the circuit. Then we got the voltage across the nichrome wire by using this voltmeter, and we can measure the current using the ammeter. Okay, then suppose I is the current. We use the notation I to denote the intensity of current. You know what is intensity of current? Intensity means the strength of current through that circuit. Means the quantity of charge, the amount of charge flowing through the circuit is the intensity of current. The quantity of charge flowing through the circuit in unit time from one point to another. That is the amount of charge, the quantity of charge flowing from one point to the other through this circuit is the intensity of current. Suppose we can find out the intensity of current. Suppose through this circuit 20 coulomb of charge, unit of charge is coulomb. 20 coulomb of charge is flowing through this circuit for a time of 10 seconds. The time of flow of current is 10 seconds, and the amount of charge flowing through the circuit is how much? 20 coulomb. Then charge flow in 1 second is 20 by 10, that is 2 coulomb per second. 2 coulomb per second is the intensity of current. And to denote the unit of intensity of current is, we doesn't use the coulomb per second. It is coulomb per second. Actually, it is coulomb per second, but we don't use this coulomb per second as a unit. To honor the great scientist Anthony Mary Ampere, we use ampere as the unit for the intensity of current. Therefore, I is equal to 2 ampere. Okay, that is intensity of current is the amount of charge flowing from one point to other in unit time is the intensity of current. Now you know I. Therefore, here I, intensity of current, is equal to quantity of charge by time. I is equal to Q by T. You observe that one. This I is equal to Q by T. Okay, from this equation we can find out the intensity of current. Then If I is equal to Q by T, Q is equal to I into T. If you know intensity of current and time of flow of charge, you can find out the quantity of charge. Q is equal to I into T. Now you know the intensity of current. We can measure the intensity of current by using ammeter from this circuit. Then the potential difference. The word potential difference means the difference in potential energy between 2 points. The difference in potential energy between 2 points. Suppose the current flow from one point A to B. Then we want to find out the potential difference between these 2 points A and B. Then what is the potential difference? Potential difference means difference in potential energy. That is the work done to move 1 coulomb of charge, a charge from one point to the other is the potential difference between these 2 points. That is the work done to move a charge from one point to the other. That amount of work done to move from one point to the other is the potential difference in potential energy between the 2 points. If there is a potential difference between these 2 points, then only current flow from one point to another. Always current flow, even though not only the current, any particle move from higher potential to lower potential. Therefore here current flow from one point to the other. If you want to flow, if the current to be flowed, or if you want to flow the current, then there should be a potential difference between the 2 points. Therefore, the potential difference between 2 points is the work done to move a charge from one point to the other. If the work done to move 1 coulomb of charge from the point A to B is 1 joule. That is work done to move 1 coulomb of charge from one point to the other is 1 joule. Then the potential difference between these 2 points is 1 coulomb. 1 volt. Okay? That is the potential difference between these 2 points is the work done to move charge from one point to other. The unit of potential difference is volt. The unit of charge is coulomb, and unit of work is joule. Therefore, the potential difference between 2 points is 1 volt if the work done to move 1 coulomb of charge from one point to the other is 1 joule. Okay? The remaining part. Our question is remaining there. How does this nichrome convert electrical energy into heat energy? Yeah, now you know the relation between intensity of current, charge and time, and also the meaning of potential difference. The remaining part that we can discuss in the next class. Okay, thank you.